Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss inverse Laplace transform and its properties. Let's begin. As we know that f of s is the Laplace transform of a function f of t, that is Laplace transform of the function f of t, that is f of s. Then the function f of t is known as inverse Laplace transform and it is denoted by L to the power minus 1 f of s, that gives rise to the function f of t, where L to the power minus 1 is called inverse Laplace transform operator. Inverse Laplace transform operator, and f of t is known as the inverse Laplace transform. Let us discuss the inverse Laplace transform of some elementary functions. As we know, when a function let f of t is equal to 1, then Laplace transform of that of given function, Laplace transform of 1 is equal to 1 divided by s, as we have already derived in case of some elementary functions of Laplace transform. Then if we take the inverse Laplace transform of 1 by s, then it gives rise to 1. Same concept is used to evaluate various types of inverse Laplace transform of some elementary functions. Inverse Laplace transform of 1 divided by s to the power n is equal to t to the power n minus 1 divided by n minus 1 factorial. As if we calculate the Laplace transform of that given function, then it gives rise to the result 1 divided by s to the power n. Inverse Laplace transform of 1 divided by s minus a is equal to e to the power at. Inverse Laplace transform of 1 divided by s square plus a square is equal to 1 by a sin a t. Again, s divided by s square plus a square inverse Laplace transform as cos a t. 1 divided by s square minus a square inverse Laplace transform as 1 by a sin s a t. Similarly, for s divided by s square plus a square, it will be cos s a t, and inverse Laplace transform of s minus a divided by s minus a square plus b square is equal to e to the power a t cos bt, and s minus a divided by s minus a square minus b square is equal to e to the power a t cos s bt, and 1 divided by s minus a square plus b square, its inverse Laplace transform as 1 by b e to the power a t sin bt, and 1 divided by s minus a square minus b square is equal to 1 by b e to the power a t sin s bt, and inverse Laplace transform of the function s divided by s square minus a square whole square is equal to 1 by 2a t sin a t, and f of s minus a is equal to e to the power a t f of a t, its Laplace inverse Laplace transform. Similarly, s square minus a square divided by s square plus a square whole square, its inverse Laplace transform as t cos a t, and 1 divided by s square plus a square whole square, its inverse Laplace transform as 1 divided by 2aq equal into sin 80 minus 80 cos 80. These are some basics of inverse Laplace transform of some elementary functions. Next we have to discuss various types of properties related to inverse Laplace transform. Some properties of inverse Laplace transform. As usual, we studied the properties in case of Laplace transform. The same properties are also useful in case of inverse Laplace transform. First, linearity property. If f of t is a function and its Laplace transform of that function f of t gives rise to f of s, and another function g of t and its Laplace transform of g of t gives rise to g of s, then the inverse Laplace transform of c1 fs plus c2 gs, c1 and c2 are the constants, then we have c1 inverse Laplace transform of f of s plus c2 inverse Laplace transform of g of s, whereas c1 inverse Laplace transform of f of s is equal to f of t plus c2 inverse Laplace transform of g of s is equal to g of t. Here we prefer c1 and c2 are constants. This one is the linearity property in case of inverse Laplace transform. Next, shifting property or translation theorem. There are two shifting property, fast shifting property and second shifting property. Fast shifting property if inverse Laplace transform of f of s is equal to f of t, then inverse Laplace transform of f of s minus a is equal to e to the power at f of t, which is equal to e to the power at in place of f of t. That one is the inverse Laplace transform of f of s. This is the fast shifting property. Next, second shifting property. Same thing. If Laplace transform of f of t is equal to f of s, then inverse Laplace transform of the function e to the power s into f of s is equal to f of t minus a u of t minus a. These two are the shifting property or translation theorem in case of inverse Laplace transforms. Next property, change of scale property. In case of inverse Laplace transform, change of scale property as inverse Laplace transform of the function f of as is equal to 1 by a f of t by a. As usual, the function is given as Laplace transform of f of t is equal to f of s. Next, inverse Laplace transform of derivatives. Inverse Laplace transform of the function nth order differentiation fn s is equal to minus 1 to the power n t to the power n, the function f of t, whereas n stands from 1 2 3 dot dot dot. Similarly, for inverse Laplace transform of integrals, we have as usual techniques. If inverse Laplace transform of f of s gives rise to f of t, then inverse Laplace transform of integral limit from 0 to infinity f of u du is equal to f of t divided by t. Next, if s is multiplied, then what should be the inverse Laplace transform? If inverse Laplace transform L inverse f of s is equal to f of t, and at 0 that function value is equal to 0, then its inverse Laplace transform of s into f of s is equal to differentiation as df by ds, differentiation of f with respect to s. If s is divided, then what should be the inverse Laplace transform? Inverse Laplace transform of s is divided, therefore it is resulted as integration from 0 to t f of u du. These are some basic properties in case of inverse Laplace transform. As usual, we studied these properties in case of Laplace transforms. It's the reverse we apply in case of inverse Laplace transform, as linearity property, shifting property which is known as translation property, as fast shifting property and second shifting property, change of scale property, inverse Laplace transform for derivatives, inverse Laplace transform of integrals, and if s is multiplied to that of function and s is divided to that of function, then what should be the inverse Laplace transforms in all these cases. Next, two examples related to inverse Laplace transform. Find the inverse Laplace transform of the function given as s square minus 3s plus 4 divided by s cube. Next question, to find the inverse Laplace transform of that function as 3s divided by s square plus 2s minus 8. Solutions as I, inverse Laplace transform of s square minus 3s plus 4 divided by s cube, that is inverse Laplace transform. S cube is divided throughout all the terms as s square divided by s cube minus 3s divided by s cube plus 4 divided by s cube is equal to L inverse 1 by s minus 3 by s square plus 4 by s cube is equal to inverse Laplace transform of 1 by s minus inverse Laplace transform of 3 by s square plus inverse Laplace transform of 4 by s cube, which one is equal to the constant terms to that of outside. So inverse Laplace transform of 1 by s minus 3 inverse Laplace transform of 1 by s square plus 4 inverse Laplace transform of 1 by s cube. 1 by s inverse Laplace transform as 1 minus 3 inverse Laplace transform of 1 by s square, that is t, plus 4 inverse Laplace transform of 1 by s cube, that is t square by 2. Then solving it, 2 1 minus 3t plus 2t square is the answer. This is the inverse Laplace transform of that function. Next question we can be solved. If that function is in that form of p as a function of s divided by q as a function of s, p by q form, and p and q are the polynomials in s, at that of case we use partial fraction to solve that kind of inverse Laplace transform problems. So here that can be solved by using partial fraction. So partial fraction can be used using partial fraction as the function 3s divided by s square plus 2s minus 8. We partial fraction that function as 3s divided by, that one is a quadratic equation, so it can be simplified as s square plus 4s minus 2s minus 8 when multiplied of two number as minus 8 and adding this two number result plus 2s, so it will be the term as 4s and minus 2s, which one is equal to 3s divided by, taking s as common, s plus 4 minus 2 as common, so s plus 4, that one is equal to 3s divided by s minus 2 whole into s plus 4. We write it as let a divided by s minus 2 plus b divided by s plus 4, as use the concept of partial fraction. Now comparing both sides, comparing we have 3s is equal to a whole into s plus 4 plus b whole into s minus 2, as taking the LCM and adding this 2, so we have 3s is equal to a whole into s plus 4 plus b whole into s minus 2. If you put s is equal to 2, therefore putting s is equal to 2, we get 6 is equal to a into 6, so 6 is cancel out, we have a is equal to 1. Then for s is equal to minus 4, then for s is equal to minus 4, for that we have we get minus 12 is equal to b whole into minus 6. Under cancellation we have b is equal to 2, so a is equal to 1 and b is equal to 2 is evaluated. Then in place of a and b we substitute its values, so the expression as 3s divided by s square plus 2s minus 8 is equal to 1 divided by s minus 2 plus 2 divided by s plus 4. Therefore inverse Laplace transform of 3s divided by s square plus 2s minus 8 is equal to inverse Laplace transform of 1 divided by s minus 2 plus inverse Laplace transform of 2 divided by s plus 4. So its inverse Laplace transform result as e to the power 2t plus 2 as constant, 2 outside, so 2 into inverse Laplace transform of 1 divided by s plus 4 as e to the power minus 40. That one is the required result of the inverse Laplace transform of that kind of question. We have to evaluate the inverse Laplace transform of these two functions by using the formula of inverse Laplace transform, and that kind of problem is solved by taking the partial fraction method, as a and b is evaluated and putted that value of a and b, and finally we expressed the inverse Laplace transform of that kind of function. So with the help of this video lecture we understand the concept of inverse Laplace transform, which is the definition of inverse Laplace transform, and inverse Laplace transform of some elementary functions, and some basic properties of inverse Laplace transform, and finally two problems related to inverse Laplace transform and their solutions. So
with this useful and informative notes, let me wind up this session. Thank you.